Hello students, am I audible?
Okay, let's start. So today we are going to understand about the Venn diagram, right? In previous classes we studied what is sets, what are different types of sets, what are disjoint sets, universal sets. So here you can see that we have a universal set, right? And this universal set is represented as a rectangular region, and whatever the inside is considered as the subset that is represented by the circle. Okay, so in figure you can say U is the universal set, this is represented by rectangle, and this circle A is the subset in that universal set. So this is the Venn diagram, okay, the basics of Venn diagram. So how we can represent the different operations in the Venn diagram? So union, this symbol is represented as the union. So A union B means all the elements of A including B elements. And definitely we know that we cannot repeat the elements, so there must be the common region. So this is set A and this is set B. If there is some common, they will also include. So A and B will be 1, 2, 3, 3, 4, 5. So 1, 2, 3, 4, 5, because 3 is going to be repeated. And we know that in the set representation, within the braces, middle bracket, we are not going to represent the same element twice. So this is just the Venn diagram. You can do it with the others also. So what are the union sets different laws? Okay, so identity law, they follow. If A union with the null set, then we will get the set A, right? Empty set is there, null set also you can say it. Like if we have a set 1, 2, 3 and we have an empty set, so what is their union? Their union will be give the set A again. So this empty set is not losing their identity, right? When going to be union with the null set, empty set, therefore it's identity element for union operation. So empty set is identity element for the union operation. When we are going to union with the universal, so definitely all the elements of A are in the universals, right? So they are going to give us nothing but universal. Okay, so here 1, 2, 3, 1, 2, 3, 4, 5 is suppose our universal set, and A is our 1, 2, 3 set from the universal. So their union is also going to give you the universal. Idempotent law, A union A is A. Okay. So when we have same sets going under the union, that's we say idempotent law. And union of set A with itself is set A. Since union combines all distinct elements from both sets, so combining distinct elements becomes represented at a one time. Same element going to be represented as a one time, so it can give the set A again. So there is no effect in our union with the set, same set. Now commutative law. See, the term commutative is come from the communication. So they are communicating with an union or not. A to B union and B to U union. So A to B union and B to A union are going to be equal, because all the elements of A going to be in the B and all the elements of B going to be in the A, and whatever the commons is going to be common out. So they are going to be equal. So either you are saying A union B or B union A, you will get the same members in their set. So it's saying that union is symmetry. The order of set does not affect the result. Associative law. See, these laws you already keep on studying from the class 6. Idempotent law, associative law, distributive law, all these laws. So what associative law saying? That union is going to be associated with the C, irrespective of the brackets. So suppose A union B and then union with the C, A union and B union C. So A then union with the B union C. What you are getting? Same element or not? So let's check it. A union B 1, 2, 2, 3, 1, 2, 3 here. A union B union C. So 1, 2, 3 and 3, 4. So 1, 2, 3, 4 we will get. And see, A is there 2, 3. And what is B union C? Right? So B union C. Okay, this why I am writing here. Okay. Now we have to check here. Right. So this is 2, 3. And again A union B union C if we will say. Okay. So I think we will check our on. So A union C. So A union B is completely 1 2 3, and we have C here. So 1 2 3 4, because 3 is not going to be repeated, correct? So this is A union C. The first condition is there, giving us 1 2 3, and the second condition you can see here. So B union C first you can see. What is B union C? So when you are going to combine with the B with the C, what is within the braces comes 2 3 and 4, because 3 is not going to be repeating again. So A union B union C means now A union 2 3 4. So 2 is not repeating 1 2 3 4. So what we are observing, that these two sets are equal, they are equal. So it's satisfying the associative law. Then comes the intersection of sets. What is intersection of set? When we have two sets, what are the things that common out will be come out in the intersection operation? So intersection of set, fundamental concept in set theory, refers to set of elements that are common to two or more sets. Now, so suppose we have a set A here 1 2 3 and set B here 3 4 5 6. You can see their Venn diagram. So what are the common region? This region is common. So this is representing our intersection. So whatever the elements come in this intersection, right, like 1 2 3 is there, 3 is coming common, 4 is also common. So 3 and 4 making the set of A intersection B, correct? Okay. What are the different laws related to intersection? Identity law, when we are intersecting with the null element, so it is giving the null element, because the common is only null. With the universal, we will get all the elements in A, because what's the common? Whatever the A region is overlapping in the U, idempotent, so they will give the intersection A, because all the elements are common. A with B, B intersection A are going to be the same. Associative law they follow, and distributive law, yes, it can also follow the distributive law. A intersection B union C. So this law is little important, you have to keep in mind. A intersection B union C. So A will intersect with the B, and then A is intersect with the C, and their union is going to satisfy A intersection B union C. Okay, let's check the differences of set. Means how we will subtract the set. Differences of set. So A minus B. So you remember we are subtracting from AB, right? So A is here 1 2 3, suppose in this region, and B is here 3 4 5. So what we will do? We will take all the elements of A, taking out B. So here 1 2 3 and 3 4 5. So 3 is common with the B. So we will neglect this 3. And what we remaining with the A? 1 2. So only the A region after deducting the B region, right? That is giving us the differences of set. Okay. So for two sets A and B, okay, A and B, symmetric differences is A minus B union B minus A, denoted by A symmetry B. So you can represent the symmetric difference. Okay. What is the symmetric differences? A symmetry B, what the mean? It means it is nothing but A minus B, then union with the B minus A. Yep. What are the properties? No commutative properties. A minus B not equals to B minus A, because A minus B will deduct all the elements of B. That elements should not be reflected in the A, and B minus A all the elements of B except the element that participating in A. A minus 5 will give us, A minus union will give us 5, because all the elements of the union will be get deducted. Differences with itself, which 5. What is the subset property? We know that all the elements of A is in the B, then it is the subset of B. So if A is the subset of B, A minus B is null element. And if symmetric there, so I already told you that what is symmetric differences. So this is our symmetric differences. So this is A minus B and this is B minus A. Okay, so this is the symmetry here. So this symmetry is represented by this del value, you can say it. Now there is absorption law and De Morgan's law. Absorption's law describes how union intersection interact with one set is the another subset. So how they are interacting with the another subset. So here you can see union absorption. So this union is going to be absorbed in the intersection of A intersection B. So A union A intersection B is equals to A, taking the union of A with its intersection with the B result in A itself. So adding the common elements of A, B to A does not change A. For example, you can see here, if we have a set A 1 to 3 element, B set 3 4 5 element. So what we are doing here, first we will find out A intersection B. What is our A intersection B? 3. You can see the 3 is common. A intersection B is 3. Okay. Now we have to do union with these 3. Which union? A. So A union with the 3. So A is 1 2 3 and 3. 3 will not represent. It is giving us 1 2 3. That is A. So what we just saw, the union absorption law is saying that A union, if with the A intersection B, we will get the again set A. Intersection union same way. If A intersection with the A union B, we will get the A again. So check it here. We have 1 2 3 and B is 3 4 5. So first of all, A union B we will do. So union means all the elements. So 1 2 3 4 5. All the elements. Repetition not allowed. A intersection, and now with intersection with which one? A 1 2 3. So how many things are 1 2 3 are common? So see, again we will get here set A. So this is the intersection absorption law. Now it's not last, but De Morgan's law is very important here. What this law is related to? It's related to complement, and we know that what is the complement of a set. When a set is given to us, the remaining elements in their universal set is going to be their complement. So De Morgan's law says that complement of unions and intersections, they are particularly useful in logic, Boolean algebra. So what is the complement? Their law, say first this one, union complement, is saying that A union B complement is equals to A complement intersection B complement. So if you have an element here, universal element 1 2 3 4 5 for the universal set, and A is 1 2 and B is 2 3. So what we will compute A union B. So when we will do A union B, so 1 2 and 3, right? A union B your will be 1 2 3. Okay. So except this is going to be A union B complement. So what are the except this? 1 2 3 4 5. Right? So you can see here A union B, and so if you will see A union B in and individually their complement. So individual complement you can see like A complement. So what are the except 1 2 3? 1 2 3 4 5. Right? And same way B complement except 2 3 1 4 5. When you are going to do their intersection, what we have? 4 5. Okay. So this is satisfying complement. A union B complement is intersection of the individual components, complements intersection, right? Same with complement with the intersection. If we have intersection and their complement, we are going to take the individuals complement union. So A intersection B, here you can check A is 1 2 and B is 2 3. So A intersection B is 2, right? Okay, A intersection B is nothing but U minus their complement. If we will try to find A intersection B, 1 3 4 5. Okay, and their individual, so 1 3 4 5. If we will take the union of their individual complement 1 3 4 5, so they are equal. So it's satisfying the De Morgan. So this is our De Morgan's law. Differences of sets we already saw. Okay, so this much is very important basis that is required for the set, and we will do some different topics, and wherever that set is required and any other theory required, we will discuss later on in that topic. Okay, students, bye, have a nice